Hey guys, Dr. Brown here with Kubo Math, and tonight we're talking Algebra 1 mixtures. So if we have various items and we're mixing them together, how do we calculate that? So let's get after it. Okay, a concentration, I have the formula for that here. Concentration equals the amount of a substance divided by the total volume or the total mass of the substance. And if you want to change that to percent concentration, you just take that same formulation, multiply it times 100. So let's make a little formula here. Let's say percent C, that equals my percent concentration, and that equals A, the amount, divided by total, whether that's mass or volume, times 100. Okay, so that's the formula we're going to use. Percent concentration equals the amount divided by the total mass or total volume times 100. So we have three problems here. Oh, this should be good. All right, 19 ounces of a can of spray. It contains 79% ethanol by weight. So when it says by weight, we're looking at mass. Okay, so how many ounces of pure ethanol are in the spray? Okay, so if we have the percent concentration equals A over total mass. In this case, we had ounces, so we had some unit of weight. And all of that's times 100. Now, in our case, what is it we have? We have percent C A T sub M in this case. What do we know? We know that our total mass is 19 ounces. And we know the percent concentration is 79%. So we know these two items, we just don't know the amount of the ethanol that's in the can. So we need to take this formula and solve it for A. So if we divide both sides by 100, we can change the percent to a different number. Let's change it to a decimal. And then if we multiply, so this cancels, if we multiply both sides by the total mass, the 100's now gone, the T sub M, the total mass is gone. Now we just have the amount equals the total mass times the percent concentration divided by 100. So the amount of the ethanol, we'll call it A sub E. Okay, so we have total mass, which was 19 what? 19 ounces. Okay, times percent, 79% divided by 100, and that equals 19 ounces times 0.79, and that equals 15.01 ounces. Now, obviously, I'd done that earlier on the calculator. Now, I try to get the students to think about a rule of thumb. I do that a lot. Of course, everyone will, when I do this, they'll all... But what that means is, if I'm trying to get an estimate for these two numbers, well, that's about 80, right? And that's about 20. So if I multiply those two together, I get 1,600. Now I divide it by 100, I get 16. So the answer is somewhere around 16. So if I go through my calculations and I get 5, I know it's wrong. That's what I would know. Or if I get 20, why would I know 20 is wrong? Because I only had 19 in total, and the percent is less than 1, the rest less than 100%. So I don't have more than what's in the can. I have less. So it has to be a number less than 19. But this gives me a good rule of thumb. I'm somewhere around 16. So my 15.01 is a believable answer. If I punch that in my calculator and get that, I can believe that. All right, so this one, 15.01. And that was the amount of ethanol, 15.01 ounces of pure ethanol that was in that 19-ounce can. Okay, let's keep that. All right, number 2, what percent juice if a 2-liter bottle has 250 milliliters of juice? Now, they're looking for percent juice. 2 liters, 250 milliliters. All right, so we have, this is T sub V this time. It's total volume because liter is a unit of volume. So T sub V is 2 liters. Now we have the amount, it's telling us there's 250 milliliters of juice in this. Now you can immediately see I have liters and milliliters. Okay, well, 2 liters, there's 1,000 milliliters per liter. So liters cancel. 2 times 1,000 is 2,000 milliliters. Now I have milliliters and milliliters, so now the units are the same. So now I can begin work. Okay. And what are they wanting to know? The percent of the juice that's in there. They're wanting to know that one. Well, recall we had percent concentration equals the amount divided by, in this case, total volume times 100. So we just need to know this. So we don't have to rearrange our formula at all. So we have 250 milliliters divided by 2,000 milliliters times 100. Well, that 0 and that 0 cancel. 25 will go into 200 8 times, so I have 1 over 8 times 100. Well, 1 over 8 is what? 0.125 times 100. Okay, so I know I'm moving the decimal point over to the right 2 places, 1, 2. So that's 12.5%. Nothing, that was the most simple one so far. Okay, so I had 12.5% of the juice, this type of juice inside that 2-liter bottle. This next one's going to be a little bit more exciting. All right, they're now going to combine 2 drinks together. Now in drink 1, I'm calling it D1, there's 5 liters of a 10% fruit juice. 5 liters of 10%, the percent concentration is 10% fruit juice. Drink 2 has 15 liters of a 20% fruit juice. So the question becomes, combine the 2 together and tell us what the overall concentration of fruit juice after combining them. Whoa. All right, so what it amounts to, the percent concentration is going to be the amount 1 divided by total, let's see, these are in liters, so T sub V plus A2, the amount in the second one, T sub V2 all of that times 100. Now that 100 could distribute to the inside, and I could have A sub 1 over T sub V1 times 100 plus A2 T sub V2 times 100. I could add those percentages together, but I think what I'm going to do at the moment, I'm just going to figure out what those are, plug them back in here, multiply that by 100. So what did we have in A1? We had this situation here, percent C1. We'll just deal with this one. I don't know A1. That's my issue. You can hear the rooster crowing outside. It's 2:30 in the morning. Why he's crowing, I don't know. All right, so let's solve this at the moment. T sub V1 times percent C1 divided by 100. That equals A1. I have to do the 100 to get to A1 and A2. All right, so TV1 was TV1 and C1, so we had 10%. TV1 was 5 liters. So I have 5 liters times 10% divided by 100, and that equals A1. So 10% divided by 100 is 0.1. 0.1 times 5 liters gives me a half a liter. Okay, so A1 equals 0.5 liters. Now percent C2, A2, TV2. All right, percent 2, we had 20% in that second drink. And we had 15 liters in there. All right, so let's change all this to 2. 2A2, TV2, 2. All right. So we had TV2, 15 liters times percent C2, which was 20%, divided by 100, and that equals the amount in 2. So I had 0.2 times 15, so it gives me 3.0 liters of that. Now then, let's go back up here. A2, 3.0 liters. And A1 was 0.5 liters. TV1, 5 liters. TV2 was 15 liters. Okay, let's clean up a little spot to work. So what do we have here? The percent concentration in total, we'll say C sub T, is 0.5 plus 3.0, and this is 5 plus 15 is 20. These are all in liters, times 100. So I have 3.5 liters divided by 20 liters. Liters cancel, times 100. And that equals, I've done this one earlier, 17.5, not liters, 17.5%. That would be the percent concentration in total by combining those two drinks together. This was mixture task. That'll be the title that I put out there. But it's just something you really need to understand, because this comes up a lot. Now it could be, instead of combining 2 of them, we do 3 of them or 4 of them or 5 of them. So that could happen also. But it's the same concept, working through multiples as there is this. Okay, why are we doing this? Together we're trying to build a better tomorrow, and do that through math. Study, guys. Study, study, study. All right? That's all for now. We'll talk to you next time. Thanks.